Let's look at some optical illusions for a change. These are usually quite fun, and you can learn a lot from an optical illusion. We're not going to show you the greatest hits. There's too many of these. It's something of a sport to come up with new illusions all the time. And we're going to start off with the most boring one possible, for which I don't apologize. There's still something to be learned for this. This is the Muller-Lyer illusion, and I'm sure you're sick to death of it. You've seen it as a child. You probably weren't very impressed back then, and you're probably still not very impressed by it. The basic finding is that when you look at lines laid out in this fashion, although the central line segment of the two figures is the same length, the lower one looks shorter than the upper one. Now, how should we understand something like this? There seems to be a mismatch between the reality we can measure and what we perceive. It seems like perception isn't doing a good job here to some extent. One way to approach this is to note that these are very, very abstract patterns made up just of line segments. And so perhaps all we've learned about the brain might encourage us to go look for some defect in the manner in which abstract patterns of line segments are put together. That would be to assume that this is a low-level visual phenomenon, which is somehow induced by the building of constructive representations from small pieces, which are somehow put together inappropriately. But that's not what's going on here at all. There was a very interesting study done in the 1960s in which people from collectives that are normally not studied in scientific psychological studies were included for once. Now, it's a sad and tragic fact that most of the findings of scientific psychology have been obtained by experimenting on white educated students from American universities taking psychology courses for credit, as if they could stand for humanity. So this is a rare case of going beyond that. And you can see from the slide there are many African groups included, and some non-Africans. One way of looking at this illusion is to measure the discrepancy between the true length of the lines and that which is perceived. To do that, what you do is you artificially lengthen the lower one until it seems to be at the same length as the top one. That's the point of subjective equality. And the more you have to stretch it, then the stronger is the illusion. At the bottom there, you can see data that measures the strength of the illusion for diverse cohorts. Out at the second entry on the right-hand side is Evanston. This is north of Chicago. Northwestern University is there, very elite university and entirely typical of the sort of university that generates these kinds of results, because that's where a lot of scientific psychology goes on. And the effect is very strong there. The effect is weaker for all the other groups and disappears for some of them. Adults and children are plotted separately, but that's not of particular interest to us here. What's of interest to us here is to ask, why are there some groups for whom this doesn't happen, while there are some groups for whom this is a very strong illusion? You'll notice the two on the left-hand side, South African miners and San. The San are the Bushmen of the Kalahari Desert. So both groups are from southern Africa, and both the miners and the San have this in common. They spend most of their time in environments that are rather different from the environments that students in Northwestern universities spend their time in. I suspect you're in an environment right now that more resembles that typical of these students. If you look around you, see, are there any carpentered edges around you? Do surfaces meet at right angles? Are you in a building with walls? Are you at a table or a desk? Are there windows around? These are all entirely unsurprising elements in our environment. What they have in common, though, is a feature you might not have noticed, which is they generate right angles. Right angles arise when engineered surfaces are put together, and when three of them arise, then we get a configuration of edges which resembles exactly this. That is, in a three-dimensional world structured by planar surfaces located at right angles to each other, these kinds of patterns provide important depth information. They're telling you a lot more than the presence of lines on a page. They're telling you about surfaces that come together and something about the geometry of your surroundings. The San Bushmen and the South African miners, who spend an awful lot of time underneath ground, do not have this in their environment. So we can see here that what looks like a low-level visual artifact is in fact conditioned by the properties of the culturally inherited environment. Getting very difficult to keep nature and culture apart once again. Now, I teach this course quite a lot, and in 2015 we had just covered optical illusions when this happened. You may or may not be familiar with this because some years have passed, but in 2015 this photograph of a dress basically broke the internet. Someone took this photograph at a wedding, and it was quickly realized that people seemed to see it in one of two ways. Either they saw this dress as being basically black and blue, or they saw it as being white and gold. And most people could not be shifted from their interpretation of it. We're not, unfortunately, in a classroom setting right now, but every year I have put this up and I've asked how many people here see it one way and how many people here see it the other way. And what we found was that every year about half the class sees it as blue and black, and about half the class sees it as white and gold. I confess I belong to one of these camps and not the other. I see it as white and gold, although the correct answer is blue and black. And I cannot see it in the other way. Now, because this was an internet phenomenon and funny thing that people passed around on Facebook, an immediate huge experiment was conducted accidentally. So responses were collected, were available from hundreds of thousands of people, and they broke down almost 50-50. This is remarkable, showing that this unique, odd photo provides a very interesting landmark for visual illusion. Now, why does this arise? Well, the first thing to notice about this photograph is it's a terrible photograph. You can see the dress, but you can see very little of the conditions around the dress. You have very little information about the kind of lighting that's in place, about how other surfaces with perhaps predictable characteristics might appear. And this is crucial. This little diagram illustrates the fact that if you look at this, the figure on the right, excerpted, shown against a blue background, uses the same tones to illustrate white and gold as the figure on the left against the yellow background, where the same tones now appear to be blue and black. There's been tons of discussion about this, and one of the readings for this week will be a paper that looks into this in great detail. But the important point for us is this. Vision is a way of making sense of the world. This photograph does not help you to make sense of the world because it doesn't provide contextual information that you would need to make sense of the world, and so your perceptual system takes a blind guess, to be honest with you. If we see vision as solely taking information that is already there, we will miss this important fact. If we see vision as a form of active engagement with the world by which we make sense of it, this seems less surprising. So here's one of my favorite illusions. This is an old chestnut again, and it makes use of a device that optical illusions often do. You remember we had the gray haze outside a specific dot, and we asked you to focus on the dot, and when you did, the haze went away. When you moved your eyes, it came back. And we've noted that movement of the eyes is a normal condition for vision. It's not a pathological condition for vision. Very, very many optical illusions are built by asking you to stare at a fixed point. In this case, you're going to stare at the cross in the middle of the screen, and then weird stuff happens. And it stops again once you move your eyes. Before I start this, let me tell you what's going to happen, because it sounds quite fantastic. First of all, you're quite clear that what you're seeing there is a circle with one element missing of purple dots. What's going to happen when I hit go is that the place at which the dot is missing is going to travel around the circle. So alternately, dots will blink on and off, such that the missing dot travels around the circle. That's what's actually happening, and when you can move your eyes, you'll see that. But if you keep your eyes fixed on the fixation point, what's going to happen is completely different. A green dot is going to magically appear from somewhere and swallow up all the purple dots. Sounds unlikely, doesn't it? Let's have a go. Yep, did it for me. So this once more clearly illustrates the odd things that happen when we fix vision. And an awful lot of vision has been studied by fixing heads, and this seems to be inappropriate. The staying still is not the way that we normally see things in the world. Now, we don't have time to go into all these optical illusions. They are great fun. They're so much fun that every year there's a competition for new illusions, illusionoftheyear.com, and I recommend that you go there and have a look at it. I'll put a link to that in the resources for this video. But most of these are optical illusions, and an awful lot of them work by inducing a pathological state of fixation. But that by no means exhausts them. They're always interesting because each illusion tells us something about how seeing works. Here's a very famous paradoxical figure. It's not optical, I don't know, it's an optical illusion. When you look at this, what you seem to see is a staircase that goes up or down forever. And it's by the Belgian artist M.C. Escher, who is very famous for this. And here we can illustrate this. Here's someone going to fall down the stairs forever. Somehow got an even shorter straw than Sisyphus in hell. Now, what I want to show you is an auditory illusion that resembles this. You can clearly see it in which one goes down forever. But can you imagine something like this in a different modality? I'm going to show you an auditory illusion. Is there such a thing as an illusion of smell? Does that make sense? Perhaps there's ammonia in the room and you smell lemons. Would that count as an olfactory illusion? And is it likely to happen? I don't know of any olfactory illusions, but I do know of some auditory illusions. Here's one, a tone that seems much like the staircase to go up forever. Each tone clearly higher than the last, but somehow never really getting anywhere. It's quite a clever illusion, that. It's built for those who want to know and dispel the magic. By combining two tones, this is not a single sinusoid with a single frequency, it's rather two tones of the same octave, an octave apart, and the relative intensity of them varies, so that as the fundamental pitch goes up, we introduce more energy in the lower frequencies, such that by the time we reach the last one, most of the energy has looped around to the start. That's an informal explanation. I don't really want to destroy the magic. That's an auditory illusion. Right, we've only one more video in this section.